I don't know what the integral of inverse tangent is, so I'm not letting that be dv. And then I think to myself, if I let this be equal to u, oh yeah, the derivative of this thing has a simple algebraic form. It's 1 over 1 plus x squared. And so instead of having this weird inverse tangent thing, I have a simple algebraic expression, and that's a win. So I'm going to let u equal inverse tangent x. And that means du is 1 over 1 plus x squared dx. And then dv is the other piece. Well, all that's left is a dx. So let's dv equal dx. So I need to find the antiderivative there. So v is going to be equal to x. All right, so I transform my integral using integration by parts, and I have uv. So that's an inverse tangent times x itself. So I have x inverse tangent x minus the integral of v du. So there's v, and then du was 1 over 1 plus x squared. So this first piece is done. We don't have to worry about that. The second piece, I have to figure out how to integrate. And I noticed the derivative of the denominator is basically sitting up here in the numerator. The derivative of the denominator is 2x. So you're allowed to manipulate constants like that. It doesn't work with variables, but you can do it with constants. So now I have 1 over something multiplied by the derivative of that thing. That's a natural log. And this is why I've been encouraging students to not do an explicit substitution every single time you see a substitution integral, because if you have to put a formal substitution into every integration by parts problem, it just starts to get overwhelming. So I'm hoping that that's clear to look at it casually. It's 1 over some function multiplied by its derivative. So natural log of that function, this thing, must be what that came from. I don't need to worry about absolute value bars because 1 plus x squared is always positive. And you should always double check these things. So if I took the derivative of the natural log of 1 plus x squared, I would have 1 over that multiplied by the derivative of 1 plus x squared, which is 2x. So when I differentiate to check that integrand, it all works out. And of course, plus c because it was an indefinite integral.